Okay, so this is on Schoology, this document. And so you're going to make a presentation. It can be PowerPoint, Keynote, one of those online ones, which I can't remember the names of, whatever you want to use. You're going to need to include, you're going to be assigned a biome. And your biome I randomly assigned. Here's everybody's names and the biome you've been assigned. That is also on Schoology, so you don't have to write it down real quick. Anyway, you're going to need to include things like the temperature and precipitation. And if your biome doesn't have one of these characteristics, just write it down. Like somebody has the deep sea. It doesn't rain in the deep sea, so you don't have to worry about that. Okay, just list. You know, I won't dock you points for that. Characteristic soil type. If you're in a coral reef, there's no soil in the coral reef. Don't worry about it. Okay. So temperature, precipitation, characteristic soil type if you have soil, a global map of primary locations. Those are easy to find, just a map that highlights where your biome's found. Characteristic plant species with at least 2 specific examples and pictures. Characteristic animal species with at least 2 specific examples and pictures. 3 specific problems caused by humans. Pretty much any biome, even the deep sea, you can find some kind of problems that humans are causing for it. Potential solutions to those problems. Links to 3 websites with additional information and at least some pictures. Okay. Then sources cited. Overall production, spelling mistakes, making sure everything's in your own words. Don't copy a paragraph out of Wikipedia and not change the wording or anything. The presentation, obviously sharing it on your screen, eye contact is not going to be a big deal, but not reading it word for word, pronouncing things correctly, just doing a good presentation. And then the attractiveness of the presentation, color, graphics, effects, that kind of thing. And I have also uploaded a more specific rubric, so you can look at that and see what you need to do to get a high score. And it came up to 105, but it's going to be out of 100, so you've got 5 bonus points built into the rubric. And again, here's your biome assignments. Okay. I know everybody wants to pick their own, but I wanted to make sure everything got covered, and I also wanted to make sure that you are learning something new. So if you're an expert on a coral reef and you did a coral reef project, you may not learn much, but if you're an expert on coral reefs and I assign you swamps, you're going to learn something. Okay. Anyway, this is due Monday or Tuesday. We'll start presenting on Tuesday. And like I said, this document, the rubric, are all on Schoology. Okay. Does anybody have any questions about that? If you do, email me, chat. You can stay after class to ask me whatever you want. It's not a very difficult project. Shouldn't take you that terribly much time. And presentations are easy to make now. And just think about how lucky you are you're doing a presentation and you're doing it from behind a computer screen instead of in front of the class. So that should be easier for people that are nervous getting in front of groups. Believe it or not, I was petrified anytime I had to present during class, and now I do it every day. So it's you get used to it by practice. So anyway, that's what we're going to. That's the big assignment, and we'll go ahead and get started on talking about biomes. No, I didn't do that right. So There we go. Okay. So those of you who just came in, there is a assignment to do a presentation about biomes. You've been assigned a biome. It's on the document with the instructions on Schoology. So, okay, so let's go ahead and get started. All right, so climate and biomes. So an area's climate is determined mostly by solar radiation, the Earth's rotation, global patterns of air and water movement, gases in the atmosphere, and the Earth's surface features. And we're going to be talking about climate a lot this year. We'll spend more time on it later, but this is just to introduce it as it affects biomes. So the Earth has many different climates. First of all, what is climate? And this is where a lot of people have issues, and you know, in the middle of a snowstorm, people say they're talking about global warming and we are having a snowstorm and it's minus 10 degrees right now. There's a difference between weather and climate. And if you're out looking outside and it's super cold and there's supposed to be global warming, that is weather. Weather is a local area's short-term temperature, precipitation, humidity, etc. If you look outside and see what's going on outside, that's the weather. Okay. Climate is different. Climate is a general pattern of atmospheric or weather conditions over long periods of time. We're talking decades to millennia, long periods of time. Depending on what type of research you're doing, it may be shorter term, longer term, but it's not just this week or even this year. So, and we'll get into climate change later, and if people want to argue about it, we can. But there can be a global pattern of global warming. There could be a pattern of global warming, and you can still have cold snaps. And your general area may have a cold year or a cold winter. That doesn't mean climate change isn't happening. Okay. But on the other hand, climate is incredibly complicated. And we have been really bad at predicting even weather. We can't hardly tell you what's going to happen weather-wise in 2 weeks from now. And we're not really good at predicting how climate is changing because it's so incredibly complicated. So it is getting warmer, but it's not getting warmer as fast as we think it should. And there's several reasons for that and things like that, which we'll talk about as we go through the year. But anyway, climate, long-term, weather, short-term. So air circulation in the lower atmosphere is due to uneven heating of the Earth's surface. Obviously, the equator gets more direct light than the poles. And so there's more hot air there than there is at the poles, and that causes convection, hot air rising, cold air sinking, causing wind patterns across the globe. The rotation of the Earth bends those wind patterns, so you have circular currents. And the properties of the air, water, and land, all of these affect the climate. And in ways that it's hard to predict. Ocean currents have a huge impact on climate. Water holds a lot more heat than air does, and so you get these currents moving and changing the climate of areas where they go. The Earth's rotation bends these as well, so we end up with these circular patterns, and it redistributes the heat from the sun. So you have cold water from the Arctic areas being moved towards the equator, like here, and warm water from the equator being moved towards the poles. It just, like I said, redistributes the heat. And there's a link between the air circulation, the ocean currents, and the biomes. And not all of these links are well understood. We don't notice these effects quite as much here, but when I lived on Galveston, which is an island in a Texas island, just off of Houston, the weather in Galveston was always milder than it was in Houston. It's going to be a little bit warmer in the winter and a little bit cooler in the summer. And that's because the water was the temperature of the water affects the temperature of an island, obviously, and the water changes much slower than the temperature of inland. And we're going to talk about in a minute Britain. Let's see, is it right here? Yeah. Britain is at the same latitude as Siberia, most of parts of Canada, and southern Alaska. Great Britain. And we know about the climate of Great Britain just because so much literature is written there and we hear about it. It's colder than we are usually, but it's not that cold. It's not as cold as, say, Denmark or Siberia or Alaska. And that's because of the Gulf Stream bringing warm water right to the coast of the British Isles. So it has a much milder climate than it should, considering where it is. And if you look at this, it's in the Canadian region, and it doesn't have Canadian weather. It's an island, so it's bathed by that current on all sides, and that modifies its climate. And it's from the Gulf Stream. Okay, we also have greenhouse gases that affect the climate. And it's not just carbon dioxide. You always hear about carbon dioxide, but it's a lot more than that. Water is a greenhouse gas. There's water vapor. Carbon dioxide, methane is much more potent than carbon dioxide. And we are producing methane. It doesn't stick around quite as much as carbon dioxide does. It breaks down, but it is much more. Cattle cause a lot of problems with climate change because when they eat, they give off gases. They're farting methane. And because of the way their digestion works, they do that a lot. And they produce a lot of methane, which is a potent greenhouse gas. Nitrogen oxide. And the greenhouse effect isn't always bad. Without the greenhouse effect, our planet would be about -2 degrees Fahrenheit on average. So we like the greenhouse effect, but we're just changing it to make it worse. But without it, we would be much, much colder than we are now. I think the average global temperature right now is like 65 degrees if you average the entire globe. So -2 is a big drop. And of course, the industrial release of carbon dioxide, agricultural release of methane could cause global warming. And we talked about how heat absorption by land and water is different. Different areas absorb and reflect different amounts of heat, like we were talking about with the Daisy World. And lava fields absorb a lot of heat. Snow reflects a lot of heat. And a layer of dust or volcanic ash on snow will cause it to melt much quicker. So you cause it to absorb heat because of the dark color. And if you think about it, what do cities have all over the city? Is areas are as dark as lava fields, right? The streets, the roofs, those are all very dark areas. And so cities are in general hotter than the areas around them. We also have the rain shadow effect, and we can see this here. How often do you look to the north and you see rain clouds over Colorado and they never reach us? That happens a lot. I can see it from my house. And what happens is when you get moist, warm air hitting a mountain, it rises. And as it rises, it cools and condenses and you get rain. But it falls on the mountain. When it drops, it gets warmer. It can't hold as much water. And so by the time it gets to us, there's no moisture and we don't get the rain that Colorado does. I think right now we have had, my wife just looked it up, I think we've had about 4 inches of rain all year. That's from January to August, I think. 4 inches of rain. We're supposed to get around 10 inches in a year. To show you the differences between desert areas and other climates, where I lived 5 years ago was in the Houston area, and we would get 4 inches of rain in a single day. You know, no big deal. And we haven't had 4 inches of rain all year long. So climate makes a big difference on rainfall. Cities are known as microclimates. The buildings block the airflow. Asphalt, concrete, etc. absorb heat. Like I said, if you add up all the streets and all the roofs, that's a lot of area with a lot of heat absorption. Cities usually have higher temperatures and more pollution. They're actually talking about in some cities painting all the roofs white to try to get rid of some of this, to ease some of that heating. Okay, so how does climate affect the nature and locations of biomes? Differences in the rainfall or precipitation, doesn't have to be rain, and temperature lead to the formation of tropical, temperate, and cold deserts, grasslands, and forests, and determine their location. So the ecosystems you have are based on what's going on with the climate. And the climate affects where the organisms can live. Biomes are affected by their latitude, how far north and south they are, by their elevation, how high they are, annual precipitation, temperature. Altitude has a big difference. If you've just taken a day trip up into the mountains in Colorado, temperature drops a lot from here, doesn't it? It's a whole lot cooler. Just as an example, for every 1,000 feet, it's like going 300 miles north as far as temperature goes. And I was trying to figure out for the temperature drop we get from going just into Colorado and climbing about 5,000 feet, I would probably have had to drive all the way across Texas from Houston. Now we can do it in 45 minutes. So what is a biome? It's the largest geographic biotic unit, a major community of plants and animals with similar life forms and environmental conditions. And you can see how they're distributed. Tropical rainforests, mainly in the equatorial regions. Tropical savannas as well. The deserts, there's deserts that aren't along the equator, like us. And desert means dry, it doesn't necessarily mean hot. But they're also mainly on the interior of continents. You have your grasslands, different types of forests, and the Arctic or alpine tundra. They're distributed across the earth based primarily on climate. Therefore, in areas that are far apart, you'll sometimes find similar plants and animals because the climate is similar. These are two plants that I just think are amazing. This is an ocotillo. We have them here in New Mexico. Not so much, I usually see them more in central and southern New Mexico rather than here. We had a lot of them around Alamogordo. This is in Madagascar. They both live in deserts. Both these plants are totally unrelated to each other, not related to each other at all. And yet they have the same adaptations. The spines, the little tiny leaves, those are good adaptations for a desert. So how are they formed? Latitude affects it. The farther you move north or south, the colder the temperature gets. Elevation, the higher you go, the colder the temperature gets. So biomes usually found at cold latitudes far from the equator are also found on high mountains at lower latitudes. So like I said, a climb of 1,000 feet is equivalent to traveling 300 miles northward. So this is from Alamogordo because the sign shows up right away, but we can do the same thing here going to Colorado. There's a 5,000 feet difference. So 5,000 feet is 1,500 miles northward. So you get huge differences from Alamogordo to Cloudcroft and from Farmington to Durango or to Silverton. And it's because of the altitude. How many biomes are there? It depends on how you split them. You can have more general or more specific, but they generally decide about 8 terrestrial biomes, 8 biomes on land. There's other biomes in the ocean, which we'll talk about next. There's some disagreement about how to divide the biomes, but most can agree on these: tropical rainforest, tropical savanna, grasslands, tundra, desert, chaparral, and temperate deciduous forest. You can break some of these down. There's also temperate rainforest. There's rainforest in Oregon and Washington State. There's lots of different kinds of grasslands, lots of different kinds of deserts. Oh, and the temperate boreal forest, taiga. It's a kind of a weird word you don't hear very often, but this is basically the mountain forest, the pine forest like they have around in Colorado. So there's three major types of grasslands: tropical, temperate, and cold. Cold would be the Arctic tundra. Tropical savanna. This is like the Lion King, what you see in the Lion King. Grasslands with a few scattered trees. They have a wet and a dry season. It's in the tropics, so they don't have a lot of season as far as temperature, but they do have a wet and a dry season. It's very hot. Pretty high rainfall, between 20 and 50 inches. Keeping in mind we get 10 here. There's more species of grazing mammals here than in any other biome. If you look at the pictures from the Serengeti, you can look out and see at the same time giraffes and wildebeest and lions and zebras, all in the same area. Huge numbers of grazing mammals. Then you have the temperate grasslands. Because of the dry climate, trees are only found near water sources such as streams. Between 20 and 35 inches of rain each year. And you can get pretty warm in the summer and pretty cold in the winter. So prairies are going to be like this. The tundra. Tundra actually means treeless or marshy plain. It's characterized by permafrost, permanently frozen soil, starting as high as a few centimeters below the surface. And plants can't put roots into frozen soil, so it severely limits plant growth. Winter temperatures can be down to minus 29 degrees Fahrenheit, while summer temperatures usually average around 50 degrees Fahrenheit. So very cold. Usually only 6 to 10 inches of rain or snow, but the ground is wet because there's not a lot of evaporation and it can't go anywhere. Water can't seep into frozen ground. So you get all these puddles, even though you don't get lots of snow or rain. And it stays very marshy when everything starts to thaw. And one of the problems with climate change that we've mentioned, and we'll talk about more, permafrost is soil, but it's also rotten dead plants that have been frozen for thousands of years. And when that starts to melt, when the permafrost starts to melt, all that stuff that's been stored for thousands of years will finally start to rot. And this has happened in some areas. It gets soft, it rots, and when it rots, it produces carbon dioxide and methane. And so that's something else that adds to climate change. There's some cities, maybe not cities, villages in the tundra that are having a lot of problems because they built their buildings. The permafrost starts to melt and the buildings start to sink. Because the permafrost is a nice firm foundation to set a building on, but the marshy mud that it turns into when it melts is not. And you can actually see pictures of slanted buildings where the permafrost is melting out from under them. Alpine tundra. You can see this not very far from here. You go up to Colorado, you see it. This is above the tree line and below the permanent snow line. So you get an area at the tops of the mountains where there's no trees. This is tundra, alpine tundra, mountain tundra. The plants are very small And the growing season can be as short as 7 to 8 weeks. That's the only time the plants can grow in the year, is 7 to 8 weeks. And here are some of the plants. And they don't look too odd, just normal flowers, until you look at the size of them. They're tiny, tiny little plants. And in the alpine tundra, it may not be because it may not be frozen underground, though it might, but you've got rocks underground, so you still have a very shallow soil. And it's still very cold, very short growing season. Desert. Everybody should be familiar with this one, right? As we live in one. Typically found between 25 degrees and 40 degrees latitude. Not only, typically. Rather less than 10 inches of rain each year. I think our average is about 10. Temperatures range between 68 degrees Fahrenheit and 77. Some extreme deserts can reach temperatures higher than 100 and lower than 5 degrees Fahrenheit. One that I'll mention here, much lower than 5 degrees Fahrenheit. This is just typical. Deserts have a pretty wide range of types. Everything from us to Death Valley. You know, we have a fairly mild temperatures here. It doesn't usually get over 100 degrees too often. And it doesn't get super, super cold too often, though my first negative temperatures I've ever witnessed were here. But plants that live in the desert, it's hard for plants here. A lot of them will lose their leaves during long dry spells. Some have no leaves. Think about the cacti. And they conduct photosynthesis in the skin of their stems. Leaves are great for photosynthesis, but you lose a lot of water through them. Animal strategies: store water, conserve water, hide in the day. There's a lot of animals that you don't see in the heat of the day. Some of them become dormant during extreme heat. And deserts are everything from things like this, like the Sahara. Tropical deserts, hot and dry, very hot, very dry. Temperate deserts. Daytime temperatures high in the summer and low in the winter. The Mojave Desert, most of New Mexico, is a temperate desert. So we have fairly cold temperatures in the winter, fairly high temperatures in the summer. And there are also cold deserts where the winters are very cold and the summers may only be warm. The largest desert in the world is the Antarctic Desert. Antarctica is a desert going by rainfall or precipitation. Very little, it's very dry. Of course, whatever precipitation you get stays there because it's frozen. But most of the continent of Antarctica is a single desert, the Antarctic Desert. It's kind of weird we don't think about cold areas being deserts, but they are. Okay, chaparral. This is found between 32 and 40 degrees latitude, usually on the west coast of continents. Receive between 35 and 70 centimeters, 13 to 27 inches of rain. Still pretty low. They usually get it in the wintertime. Extremely resistant to drought and weather events. Unfortunately, a big problem they have is they burn easily. So a lot of the areas in California that are on fire are chaparrals right now. Tropical rainforest. Typically found near the equator, they're tropical. Receive more than 200 centimeters, 78 inches of rain, over 6 feet of rain in a year. If you can imagine that. We get 10 inches, they get 6 feet. Temperatures are usually between 68 degrees Fahrenheit and 77 degrees Fahrenheit the entire year. Some areas are much warmer than that. If I tell you it's 77 degrees Fahrenheit in the rainforest, is going to feel way hotter than 90 degrees feels here because it's going to be 100% humidity. So 50% of the world's animal species can be found in the tropical rainforest. You can imagine that huge biodiversity in the tropical rainforest. And when we get to biodiversity, we'll talk about that more. So they have stratification of specialized plant and animal niches. Things that there's layers in the rainforest. They're very tall, and things at the bottom are going to be very different niches than the ones that are at the top of the plants. Not a lot of wind. Rapid recycling of scarce soil nutrients. So there's lots of nutrients bound up in the plants. Problem with that is people want to live in the rainforest, and to live there they need to farm. So what they do is they burn the rainforest down and then plant their crops. And it's a rainforest. You would think it'd be hugely fertile. Unfortunately, most of the nutrients are in the plants you just burnt, and most of them went up in smoke. And what little is in the soil is usually gone after 3 or 4 years of farming. So you farm for 3 or 4 years and use up all the nutrients, and your crops won't grow. And then you either have to fertilize or you have to burn down another section of rainforest to start again. And that's why there's huge deforestation going on in many of the rainforests of the world. Some of it's from lumber, but a lot of it is just from burning down the trees so you can plant crops. And there's things people are trying to do to change that, planting things like coffee that can grow under the trees, using some of the things that grow in the rainforest as cash crops. So lots of things that we're working on, but there were times when I lived in coastal Texas that we had smoke in the air, kind of like we do here, only ours was coming from Central America, from burning rainforest. It didn't happen often, but it did occasionally. Okay, temperate deciduous forest, the taiga. This has a moderate climate. Most of the trees will lose their leaves in the winter. Temperature range is between minus 30 degrees Celsius, minus 22 Fahrenheit, 86 degrees Fahrenheit. Average 30 to 60 inches of precipitation. Okay. And this is wrong. I need to fix this. The taiga does actually not go here. So this is not taiga. This is temperate deciduous forest. Well-developed understory. This is like the hardwood forest where most of the trees lose their leaves. Boreal forest. This is the taiga. I'm not sure how that got messed up. Typically found between 45 degrees and 60 degrees north latitude. Cold climate, summer rains. Very few reptiles because it's cool. Limited understory, so it's easier to walk through. And snow is the primary form of precipitation. So when you go up to Silverton and hike in the forest there, those are taigas, temperate boreal forests. You get a lot of snow. And you have mostly pine trees. They have the little tiny leaves which are adapted to shed snow so they don't break. If you get deciduous trees with the great big leaves, like aspen trees and cottonwood trees, if it snows on them before they lose their leaves, then a lot of times the branches break because so much snow catches on those big leaves. Okay, so that's all we'll do for today. On Thursday, we will talk about aquatic biomes. And go ahead and get started on your presentation. If you have any questions about it, feel free to ask, and you can ask me in any of the office hours after class, or you can send me an email, whatever. So have a good day. I don't have anything else for you. If you don't have any questions, you can leave.